Okay, so we're live again.
Yeah, didn't work last week.
Oh, didn't it?
No.
Uh,
Anyway, hopefully it'll work this week.
yeah.
Alrighty, looks like we're up and running.
There was a countdown of sorts there. So.
Nice. It's an of sorts countdown. That's what it is. Yeah.
Well, everything's of sorts on this show.
Yes, that's true too.
It's a podcast of sorts.
Yes.
That would be the ultimate compliment, wouldn't it? Oh dear.
I'm having. Okay. All right. I'm good. We best do the TikTok, I suppose.
Oh, yes. Yeah, I better remember what. Oh, yeah. Okay, good.
Here we go. In 3, 2, 1. Hello again, Andrew Dunkley here from the Space Nuts podcast. Hope you're well, and I hope you can join us on the next episode 315, because we've got a lot to talk about. And joining me will be Professor Fred Watson, astronomer at large. What's coming up, Fred?
We've got a bumper-packed show for our listeners this week, as always. Going to start off by talking about a brand new telescope that has just been launched into space, but launched into its mission at Siding Spring Observatory in northwestern New South Wales. And we're going to talk about whether we should be looking closer to the sun to find near-Earth objects.
Oh, yeah. Well, we do want to find them, don't we? Because we don't want any running into us or wrecking our Saturday shopping trips. No, definitely not. We will also be answering some audience questions. Andrew from Vancouver is following up what happens next with the New Horizons probe, because it's sort of finished its mission a couple of years ago. And Neil in Sydney says the sun sucks. Why? We will tell you on the next edition of Space Nuts. Download from your favourite podcast distributor. There we go.
Sounds good.
Yeah, it should work. All right. Now I've just got to get my ducks lined up here, as always. And where's the opening bell? There it is. Okay. I'll give this here a rest. I should have had a shave this morning. That looks dreadful.
No, you look all right. You're, there's no, I can't detect anything. In fact, you look better than me, and I did have a shave this morning. So.
I usually do, but I just I couldn't be bothered this morning. I just had one of those
some days,
minus 5,000 degrees. I really don't want to. Really don't want to do this. Okay, let us get this show on the road. Here we go in 199. No. 3, 2, 1. Hello there. Thanks for joining us. This is Space Nuts, where we talk astronomy and space science every week. And my name's Andrew Dunkley. I'm your host. And coming up on this episode, we're going to look at a new telescope, which has just been launched or officially opened by his good self, Professor Fred Watson. We'll tell you all about that. There's another hole in the James Webb Space Telescope. Well, let's call it a dent. It's not a hole, but it's a dent. And they found some string on Mars. Is it Martian string, or did it get there some other way? And somebody wants to get up close and personal with near-Earth objects. That's their game. We'll also be answering audience questions about New Horizons. And is there a better place to live than the sun? Well, not on it, but around it. Apparently there might be. We'll get into all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as he tends to do every week, because he's got nothing better to do, really, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Yeah, one day I'll find a proper job or something like that.
One day. You know,
Sure.
No rush on these things.
Really?
Hey, I went to Canberra last weekend.
Oh,
This is a lesson to everybody. do your homework before you plan a visit to a place like Canberra, because they might be renovating something that you wanted to go and see.
Oh dear.
Yeah,
What was it?
the Australian War Memorial.
Oh, really? Okay.
One of my
Yeah.
favourite places in the world. I adore the place. Haven't been there for so very long, and we thought, gosh, we're retired now. Let's do a road trip and drive 5 hours to go and see the Australian War Memorial, only to find out that it's renovated, so it's a bit more of a low-key opportunity situation. Not all the exhibits are actually open, and they've got it sort of set up for very limited exposure, and so you get to spend 2 hours there. 2 hours. This is all we got. But it was still very, very enjoyable and enlightening, and it's very, very different. Lots of new things that I hadn't seen before, so that was great. But yeah, got to go back now. But,
Of course you do, yeah. Is G for George still on exhibition?
No, he's off exhibition. And for those who don't know what Fred's talking about, G for George is a Lancaster bomber from World War II. Beautiful, beautiful aircraft. I love G for George, but no, I couldn't see him. Saw a Spitfire, saw a Mustang, saw a Zero, saw a few other planes. I spent most of my time in the World War One part of the War Memorial because of
More your
my
generation, really.
historical interest in it, with my grandfather and his brothers fighting in the First World War. But and that was quite amazing. And I know I'm really happy they've still got the dioramas there that rather than photos or pictures or whatever of the major battles of World War One, they did them up in dioramas, and they look amazing. So it's like you're looking at the thing as it happened. And the one at where the Second Division had that great victory and pushed the Germans all the way back to the Hindenburg Line is still on exhibit. And my grandfather was right in the middle of that battle, so I was glad to see it was still there.
He might be in the diorama.
Yeah, well, who knows? Well, there is a Lewis gun crew in the diorama, and he was on a Lewis gun crew. So, yeah, could have been him. Yes, so that's what I've been up to. And Fred, you've had a busy time of it too.
Last week, that's right, in Siding Spring Observatory, where the National Optical Astronomy Observatory is, including the largest telescope in Australia, or the largest visible light telescope in Australia, the Anglo-Australian Telescope. And we might say a bit more about that in a minute.
Yeah, why not?
Yeah.
Well, let's start now, because there's been some happenings at Coonabarra.
Yeah, that's right. So the reason why I was there last week was to do the honours in opening a new telescope there, which is a very unusual one, and one that I think is quite exciting for various reasons. Most notably, and I guess, excuse me, this is the thing that singles it out from most other professional astronomical telescopes of any size. This one was made from off-the-shelf components. So things you can, you can't exactly go into your astronomy shop and buy them. Photographic shop and buy them, but you can, if you talk to them, and I might as well mention their name, it's Canon. These are lenses that are off the shelf. They're lenses that are normally used for wildlife and sports photography. So they're fast lenses, f2.8. That will mean something, I'm sure, to many of our listeners. And they have 400mm focal length. So that they're big optics. The diameter is like 5 inches or thereabouts of the lens, and that length, 400mm, is actually that long, the unit, because it's all optics, things of that sort. But it is they're very, very sizable lenses and exceedingly good quality. But so let me finish the story. There are 10 of these lenses in the telescope, whose name I should tell you, which is Huntsman. And you will know Huntsman as an Australian spider.
Yep.
It seems to be fashionable among builders of instruments for astronomy in Australia these days to give them names from Australian wildlife. I've been involved with the Funnel Webb project and the Taipan project and the Echidna project, but not Emu or Wallaby, which are actually radio astronomy projects.
Right.
So Huntsman, and of course the other reason why it's called Huntsman is how many eyes Huntsman have?
I'm going to say 10.
I think it's 8.
Oh,
Could be
okay.
right. I think they've got more than one. That's the thing, on more than
Yeah.
2, and that's of course the link, because it looks like looks a bit like a spider with all these eyes. So that's how the thing is set up, and it's on a high-end, very high-end telescope mounting to make sure it tracks the sky supremely. But what is particularly suitable for this work is the coatings on them. So you probably know that lenses have what we used to call anti-reflection coatings, which basically means that you don't get light reflecting off the lens surface as well as going through. If you have a glass surface that's got no coating on it, about, if I remember rightly, about 5-6% of it is reflected back the way it came, and
Yeah.
the other 94 and 95 goes through into the lens. And if you've got a lens with 20 optical surfaces and you don't put coatings on them, by the time you get to it, you've just got this dribble of light coming out by the time you get to the end, the image plane. So optical coatings have been applied actually since the Second World War, and in fact since the 1980s probably, multi-layer coatings have been applied, which actually reduce even further the amount of reflection coming back. But these lenses have got a nanostructure coating on them. So there are these tiny little dimples, I suppose you'd call them, or not indentations, they come outwards, I think, rather than inwards. Little protuberances, which are smaller than the wavelength of light. And these nanomaterials can actually make a huge difference to how much light is reflected back. So your coating process becomes not so much putting a thin layer of some of the material on, which is what normal coatings do, but these nano structures on, which essentially gets rid of the reflections altogether. Why is that important? Not just because you're losing light, it's because reflections inside lenses, basically that means light's bouncing around in there and it finds its way into the image where you don't want it, stuff that should, it's just bounced out around between the lenses. And that is what makes the images provided by these lenses clean, very, very free from any sort of reflected, what we call ghost images actually within the lenses. So they're very clean, and that lends them to their purpose, which I knew I'd get to eventually, and I think I'm nearing it at the moment. There's a number of things that you can do with Huntsman, but one of them, and one of the main reasons, and this is what drove the principal investigator, Dr. Lee Spittler, who's really the genius behind this, and who sadly missed the opening because he went down with COVID. He foresaw the benefit in this really clean imagery for projects where you're looking for very, very faint light between galaxies, because that is not scattering within the telescope. A more conventional telescope with just a big mirror or something would have scattering that would swamp out that very faint light that you're trying to find. Why is that faint light there? Because it tells you about collisions. If you've got two galaxies that collide, or another smaller galaxy passes through a larger one, you get debris thrown off in the shape. But these things are so far away that those stars just merge into a very, very faint background layer of light. If you can track where that light is, you can get some insight into the physics of these collisions, how they've happened, and in particular what might happen when our galaxy runs into Andromeda in 3.5 billion years or thereabouts.
Yeah.
So it's all about studying these deep phenomena in space in a way that you can't do any other way. So you've got to take your hat off to Lee and his team, and I should mention Sarah Caddy and her colleagues, who is a PhD student, and her colleagues at Macquarie University, which is the institution responsible for this, with whom I have an honorary position, I have to throw it in, and an honorary doctorate as well. They gave me that a couple of months ago. So I'm saying all the right things about Macquarie, but it's a fantastic project. I was delighted to be asked to come and help to open it. I'm really happy about the way the thing's going. I think they're going to see really great data. There will be a lot of really new information about colliding galaxies that comes from it. And the best thing is, Andrew, because it's a modular construction, you can add to it. So, if they manage to save up a few more dollars to buy some more of these lenses, then you can essentially improve the size of the telescope. You make it bigger, make it 20 lenses perhaps.
It's a very impressive looking device, I must say.
Yeah.
And it does look like the array of a set of eyes from a spider, the way it's set up. It really does have that look about it. This little cluster of eyes peering at you and thinking, oh, I'd like to eat that.
Well, that might be what it's thinking when it looks at the galaxy.
Yeah, maybe.
I might just throw in one more credit that I haven't mentioned, and that is that the idea was inspired by a telescope which uses the same lenses and a similar configuration, but it's in the northern hemisphere. In fact, it's called Dragonfly. I think it's in New Mexico, if I remember rightly, and that's where it operates. And so now we've got this both northern and hemisphere coverage with these quite unique telescopes. Certainly Huntsman is the first one in the southern hemisphere.
Fantastic. Well done to everybody.
Yeah, I think so too. Good on them all.
And apparently after Fred finished his speech, everybody had gone home to bed. Now, let's move on to our favourite...
How did you know that?
Because you only talk in really short bursts, Fred. That's how I know that. Yeah. Now, let's move on to our favourite subject at this time, and that's the James telescope, which has got another dent in it.
Yes, there's a micrometeorite. Sorry, let's get it right. A micrometeoroid, because meteoroids are what fly through space, meteorites are what hit the ground. Yes, a dent which happened sometime between the 22nd and the 24th of May, but has really only been analysed within the last few weeks. And
I love the way they describe this damage. Significant uncorrectable change.
Yeah. I thought, gosh, the
it's all over Red Rover.
It's all over, yeah. Whoa, that didn't last long, did it? But actually, when you read further, excuse me, it is something that's uncorrectable in the sense that no matter how much adjustment you do to the mirrors themselves, and that's what you can do, you can actually do quite a lot of adjustment, it's still got a dent in it. So the good side is that so far, from what I've read, they've got the images themselves show no degradation whatsoever. So there's a dent. It's in the C3 mirror. See, I read my stuff.
Okay.
I should explain that actually. There are three types of mirror, which are called A, B, and C, and they have each has the same curvature. And if you can imagine this array of hexagons, you're going to have some that will be the same distance from the centre, which is what it's really defined by. So the A, B and C types all have different curvature. This is a C3, number 3 in the C series. And it's got this dent. And they've done adjustments. You don't have to look far on the web to find before and after images, which are the wavefront images that give you an idea of the mirror quality or the error in the mirror. And you can see there's a white spot in the C3 mirror.
Yeah, it makes you wonder if that's twice now it's been dinged, I think.
It
makes you wonder. 19 times. 19
so
times. It does sort of...
that have been big enough to be reported, yeah.
Yeah, gosh.
Is it in the right spot?
That's what I was trying to get at. If it's going to get hit so many times in such a short period, what are we going to be talking about in a year?
Yeah, that's right. They're all dinged. I think, I mean, all we hear about this is that the modelling that was done beforehand, before the telescope was put there, indicated that this problem would be within tolerances, that it would be, nominal, if I can put it that way, to have few impacts. But I think the two of them, I mean, there was that one that knocked the mirror slightly out of adjustment, which they managed to correct okay. And this one, which has been corrected up to a certain level, but there's still evidence that it's there. That does make you wonder, because it's only been in space for 6 months or something.
Yeah. And it's copped a bit of a shellacking at this point in time.
And I guess you know, given where it is, the second Lagrange point, so it's a gravitational null point where you can have stable spacecraft in orbit around this point, and there's a number there. Gaia's there. Gaia, the spacecraft that looks at star positions. Planck is there, I think. In fact, it maybe even WMAP, the Wilkinson microwave anisotropy probe. I forget all these, but there are several spacecraft in that vicinity. So they must know about the dust impact levels. But you would think intuitively that a place where it's gravitationally stable would collect dust, interstellar dust. And we know that some of the other Lagrange points that involve the moon do have dust clouds on them. They've got a name. The 60-degree ones before and after the moon have got, one of them has got a detectable dust cloud there. So they do collect dust, those stable points.
Yeah. Well, let's just hope that it doesn't continue.
Yes.
Or they don't get bigger.
Bigger, yeah, that's right.
All right. I was going to move on to our next story straight away, but we might take a breath and deal with that after the break. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson. Now, Fred, I need you to check something. We've got some audio dropouts.
Okay.
So I'm wondering if there's a cable loose, and your audio overall is quite soft. So I just might get you to double check which microphone you're plugged into.
It's definitely the Rode mic.
Okay. It just sounds a bit off.
Let me put the gain up a bit or something like that. That's my speaker gain, I think. What does that sound like? Any better?
Same.
Same. It's a bit weird. Okay. Just hang on.
Have you got a microphone icon at the bottom of the screen?
Yeah, I'm just going to have a look just to make
Hover
sure.
over that and see what's ticked.
Yeah. Oh, you're right. It's the internal mic.
I thought so.
Yeah, you're right.
Yeah.
Let me click on the road. It's going to let me do that. Yes. Really sorry about that.
No, it's okay. It's the system does default sometimes to what it thinks it should be doing, and that can mess you up.
What it's saying is you can't change devices while recording.
Oh, seriously?
We stop and I select it, or we put up with it.
Yeah,
I can hear a bit of a hiss.
Well, let me defer to Hugh.
Yeah. I'm really sorry about that. I should have checked.
No, it's okay. I'll just ask him if he wants us to stop and change mics. It'll just mean we'll have to multi-track it later, but that's okay.
Right.
Not my problem. Well, it will be, actually.
I think Hugh's listening to this.
Yeah, he might have sodded off because he's not answering me.
Oh, okay. All right.
Is there anybody out there? No.
We can briefly
I'm
mention
I'm hearing dropouts.
Okay.
Yeah. So I only got the out of okay. I knew you said okay. I reckon I'll make an executive decision. Oh, hang on.
Yeah.
That would screw the live feeds up. Oh, yeah, it would too. Well, we might work on the possibility of tidying it up in post-production. It should sound better on your drive with the local recording, so we should be able to tidy it up. Actually, I've lost you completely now. I've got no sound at all. Yeah, nothing.
Sorry, I was hovering over the mic button and must have accidentally pressed it.
Okay.
Yeah.
I did that before we started recording. Okay, let's continue then. So we'll do the string on Mars.
Yes, right. Yeah, I was hoping we'd do that.
Yeah.
String theory, I love it.
Yes. And then we'll do the near-Earth objects question. Okay, here we go. In 3, 2, 1. Now, Fred, there's been a story that sort of caught the imagination of a lot of people in the news over the last few days, and that is the discovery of a ball of string on Mars. Many saying it's probably Martian spaghetti. Others saying, where could it possibly have come from? And of course, all the tongue-in-cheek stuff's been a lot of fun, but there are theories. There are theories. And like everything we've found on Mars that shouldn't be there, it's probably been put there by us.
Yes, exactly. Possibly, it could be part of the parachutes, sort of harness that was used to slow down either Perseverance or some other spacecraft.
Yeah.
Or the I don't know whether you remember the way Perseverance and Curiosity land on Mars is with a crane, a sky crane, rather than
That's right.
the earlier versions, which kind of just bounced them off the surface, protected by a lot of beach balls and that kind of thing. So the sky crane actually spacecraft from above, lowers it onto the surface before the sky crane jettisons the cabling and heads off. And so that's the speculation that it's either a component that was used in that procedure, or a piece of cord from the parachute, or that landing system that lowers the rover to the ground, as the spokesperson for NASA's Jet Propulsion Laboratory said.
Yes.
Note that we don't have confirmation that it's one or the other.
Now,
was added to that
my
comment.
question is, did it blow into the path of Perseverance and it just happened to be time to get the photo, or did it fall off Perseverance before it blew away? Because apparently it didn't stay there very long.
That's right. So it was found, it was spotted by one of the cameras on Perseverance, and it's a front one. So I think it was lying on the ground. Perseverance was chugging along, spotted it, stopped, said, "What the something is that?" And checked it out. But then when Perseverance came back to that spot, apparently 4 days later, it had gone. And the suggestion is it was blown away by the wind. And when you see the image of it, it looks just like a tangled bit of string that would not hang around for very long if the wind was blowing.
It's got tumbleweed written all over it.
It does, doesn't it? That's exactly right. But it ain't tumbleweed.
No.
It's so the overwhelming odds are that it's something that we took to Mars. Probably NASA took it to Mars, in fact.
Well, it's not the first piece of junk that we've come across.
That's right. There's been covers and plastic covers and things of that sort. In fact, I think the aero shell of some of these re-entering spacecraft not re-entering but entering spacecraft has been found as well. Bits of trash.
There was a McDonald's fries packet too.
I didn't see that. I did see the top hat. There was a top hat there that somebody had obviously.
Good.
That was quite some time ago. There's a newspaper in Britain called the Daily Express that frequently reports on artifacts like this that have been left. It's great because they've had a picture of this rock on Mars and then a picture of a top hat next to it to show you what it really looked like.
Yeah.
And a comment by I can't remember his name, but he made a comment. He's a UFO specialist, that this was almost certainly left behind by a human who had been abducted. Almost certainly.
Almost gosh. It gives me a headache. The popular press. Anyway, that's
press,
yeah. You've got to sell your newspapers somehow, I suppose.
Yeah.
It is a bit sad though, because we're junking up Mars.
Yeah, we are. We're trashing Mars. Nowhere near as much as we potentially could do if we went in large numbers of humans. But
yes. Oh well. Anyway, it's there. Nothing we can do about it at the moment. Maybe when they send the first or second human mission to Mars, they can take a vacuum cleaner with them. Yeah. Now let's move on to the next topic. And this one I find fascinating because it focuses on something that we really haven't paid a heck of a lot of attention to. And we're talking about near-Earth objects, but we're talking about the ones that we can't see very well because they're within the orbit of our planet while they orbit the sun. And these ones are a particular type of near-Earth object, but they're also ones to worry about because they're hitting things from time to time. But the other interesting part of this story, Fred, is that the fact that they're hitting things like the Earth and the Moon and Venus would suggest they should be declining in number, and they're not.
Yes,
Which
that's
means
right.
they're coming from somewhere.
Yes, they're coming. That's right. Where are they coming from? This is Dr. Scott Shepherd, who's actually at the University of Hawaii in Oahu, probably at Moana. That's the Oahu campus of the University of Hawaii. Anyway, he's with the Institute of Astronomy there, and this is it's a kind of an op-ed piece that he's written in Science, the journal, suggesting that we have an issue with near-Earth objects that lie in the direction of the sun, and it suggests that we should be looking for them. And it's a good point because what you've got is a situation where we have a lot of near-Earth objects that orbit between the Earth and the sun. And so, because of where they are, they're difficult to see. Looking directly at the sun is not something we're used to doing. You could do it with radar and things, of course. And I think we're getting better at observing objects in twilight. And actually, twilight is when you might see these things, either morning twilight or evening twilight, when the sun's not very far below the horizon.
Yeah.
It's when you will pick them up. And it's interesting that back in February, NASA wrote a letter to, I think, the Communications Commission in the USA, expressing concerns about Starlink Generation 2, which is already approved to put 30,000 more Starlink spacecraft into orbit. They were very concerned about the effect that these spacecraft could have on our ability to pick up near-Earth objects in twilight, what might be called PHAs, potentially hazardous asteroids. So there's already been a worry expressed about the idea that Starlink satellites could be, mistaken for a near-Earth object on a collision course, or vice versa, that you could say, oh no, it's not going to hit us, it's just a Starlink satellite. He mentions that there are facilities, pretty recent ones, that do actually have the capability to study these near-Earth objects coming from the sun. And in fact, he mentions the Zwicky Transient Facility, which is actually a telescope very similar to one that we have at Siding Spring, the UK Schmidt telescope. This is what used to be called the Palomar Schmidt telescope, and is now a wide-angle telescope equipped with very sensitive detectors looking for things like asteroids or other transient events. One thing that is not mentioned in this, it might be mentioned in Shepherd's original article, but I do know that there has been a lot of thought given to and a lot of advocacy for the idea of a spacecraft orbiting between the orbits of Earth and Venus, essentially to look back at the Earth. In fact, what you could do is put it at the L1 point, the balance point gravitationally between the Earth and the Sun, which is about 1.5 million kilometers on the Earth side of the Sun, the opposite side on the Sun side of the Earth, I beg your pardon. The opposite.
Just say
side
it's to the east.
That doesn't work. It's that way. Let's say it's the opposite side to which the James Webb Space Telescope is on, because that's on the far side, on the L2 Lagrange point. If you put a spacecraft there, then it's always looking back at the Earth. And if you give it a wide enough field of view, it might very well detect some of these objects, because the ones that are passing close to Earth, of course, are being illuminated directly by the sun, and you've got, with this camera, you've got your back to the sun, so you would see them very brightly illuminated. So I think that's a good thing to do. But finally, exactly as you've said, there's an issue that the modelling that's been done on these objects that orbit within the orbit of the Earth, the modelling says yes, their numbers should be dropping, but they're not. So where are they being replenished from? Is somebody supplying the Earth objects?
Somebody? Yeah, they're coming from somewhere or something,
somewhere,
clearly.
yes. Something, yeah.
Yeah.
I think
so-
yes. I think it
I
could be
don't
the modelling that's
Well,
got
that's the other thing.
A way to go, yeah. But it's
Could
an
be
interesting
string.
Could be
Lot
a
of
string left
balls of
behind
string.
by- Oh dear.
We
Yes.
seem to lose that stuff very easily.
Yeah, and it just blows around, and next thing you know, you're taking photographs of it.
Yeah. So at this stage, it's just hang on, people. Look, we need to consider this, and that's as far as it's got so far.
I think that is. There is certainly. There has been a lot of work in terms of exploring the idea of a dedicated spacecraft inside the orbit of the Earth, looking back at the Earth to find such objects. And I think there's been quite a bit of fundraising, but I don't think we're there yet with building one of these things.
Okay. Well, let's hope nothing bangs into us in the meantime.
Indeed.
Yeah. All right. We're going to take another little break from Space Nuts. We'll be back with questions shortly. Thanks for watching. Thanks for watching if you're watching live while we record, or watching later on YouTube, or listening via your favourite podcast platform. This is Space Nuts with Andrew Dunkley and Fred Watson. Righty then. Now, questiones?
Yep.
I think I forgot to do the link in the last one. Doesn't matter. I'll do one now. Did you hear that, Hugh? I forgot to do the link in the first break. The ID thing. All right. 3, 2, 1.
Roger, you're loud and clear here also.
Space Nuts.
Question time, Fred. I've got plenty of questions, but we'll turn it over to the audience because they ask better questions than I do. And Andrew in Vancouver has a real ripper for you.
How's it going, guys? Andrew here from Vancouver Island, BC. This question is about the New Horizons probe. I don't know about you, but I was super interested in the flyby of Pluto, especially since we had not very much information or photos of the planet up until that point. I was also really interested in the Arrokoth flyby, which was, I believe, 2 or 3 years later. So my question for you is, now that it's done those science missions and it's getting farther and farther away, what is the chance that mission planners will be able to locate another object, at least for a flyby? And if unlikely, what other science can the probe do out there? Hopefully it won't go to waste, considering that they're saying it has all of its science equipment up and running. Thanks for your time.
Thank you, Andrew. Vancouver Island, my apologies. It's not exactly Vancouver. It's 3 hours across the water, isn't it? Something like that. I don't know. I'll find out next year. We're going to be there next year.
It's a lovely place, I'm told.
I expect a personal guided tour, Andrew. I do. Now, what about New Horizons getting tasked to look at another object or performing some other form of science?
Yeah, and this is certainly a real prospect to try and essentially make use of the fact that New Horizons is still in good shape, as it was after the Pluto flyby. That was very exciting. The fact that 2015, the Pluto flyby, it was.
Gosh, that time has flown.
14th of July, I think it was, 2015, if I remember rightly.
Yeah.
And then in December 2018, when Arrokoth, what we used to call Ultima Thule, looked like a snowman. I don't know whether you remember that.
I do.
And that very fitting, because it was I think it was around about Christmas when the images came back. So, and both of those flybys produced wonderful science, told us so much about certainly Pluto and its family of moons, as well as Arrokoth. And the spacecraft continues to be in good shape. So since 2020, the New Horizons research team, which is led by Alan Stern, who's he's a good bloke. I had a nice chat with him once before the flyby, actually. It was, but it's very nice to meet him. That team has been using the Subaru telescope, which is an 8-meter class telescope on mountain top in Hawaii. It's run by the Japanese, as you might expect, Subaru of course being the Japanese name for the Seven Sisters or the Pleiades. And what they're doing is essentially looking for another object that could be flown past by New Horizons. The problem here, of course, is that the further New Horizons bores into space, the fainter are the objects that it might want to look at.
Yeah.
And that's really the crux. So that's why you need an 8-meter class telescope to try and find suitable candidates. The news that I have, I don't have anything recent on this, but certainly as of a year and a half ago or thereabouts, there are none that have turned up that are within the capabilities of the spacecraft to change its trajectory. Because whatever you find, you've got to then work out a new trajectory so that the spacecraft will pass close to it. And to do that, you've got to burn fuel, and you've got a limit as to how much fuel is on board. It's still quite a lot, I think, but you might, it's not enough to make a burn to some of the objects that perhaps have been found. So that's one issue that is ongoing, and I'm sure they're working pretty hard. They worked hard to find Arrokoth. I can't remember what its name was before it was. I mean, it was Ultima Thule for a while, but I can't remember the designation it had before it turned into formally Arrokoth. But so far, there's no candidates for another flyby. But I bet that doesn't stop them looking.
No, I was going to say, but it sounds to me, Fred, like its initial project was basically all they could really plan for, and then the next step. But beyond that, it was sort of wing and a prayer stuff, because you can't really see what's going on out there too well, I would imagine.
Yes, these things are so far away. That's correct. So,
yeah,
I think New Horizons is currently, it's incredible. It's 50 astronomical units from the sun, thereabouts. Remember, Neptune is 30 astronomical units from the sun, so it's already way out it's well and truly in the Kuiper belt. There is other science that can be done, and I think we spoke about a very nice measurement that was made some months ago, where New Horizons was used to provide a much longer baseline for looking at the parallax of other stars. I think it looked at Proxima Centauri and maybe another star, so that because you're so far from the Earth, and we know the exact position of Proxima Centauri as seen from the Earth. If you can measure the position in the sky when you're 40 or 50 astronomical units away, and remember the Earth is 1 astronomical unit from the Sun, then you've got a much longer baseline to do a parallax measurement, and I think that was what was done. And that kind of thing might continue, because it doesn't really demand much energy, and certainly doesn't demand fuel if you're not making any course adjustments. One other thing that's been suggested is looking back to take a photograph of the Earth from the Kuiper belt, but that's dangerous because you've got the sun in the same field of view, and these cameras on board New Horizons don't have shutters on them. They're you'd be looking directly. The image sensor will be focused directly on the sun. You'd probably burn
and they'll burn the film.
Yeah, well, certainly burn the silicon on the detector. That's right.
Yeah, Oh well, we'll just watch with interest and see what they come up with moving forward.
Yeah,
Is
I'm
it
sure they
going to
will.
be? Is it going to be like the Voyager probes and then just head on out forever type of thing?
Yes, yeah, it's the fifth spacecraft leaving the solar system after the two Voyagers and the two Pioneers.
Wow,
It will never come back.
good grief!
Yeah, it's an extraordinary mission. I mean, its velocity now is something like 14, relative to the Sun, 14 kilometers per second. It was much higher than that when it was launched. It's slowing down too because of it's leaving the gravity potential of the Sun. But it is an escape trajectory. It will never
Yeah.
come back.
All right, Andrew, great question, really good question, and the answer is yes, but we don't know which yes, effectively. Let's get a question from the Greater Sydney region, where you hail from, Fred. Well, not originally, but at the moment. I initially thought he was just asking a question we've answered many times about the different types of stars out there. But he hones in on something that I think is a really interesting discussion point. This is Neil.
Hi, gents. Neil from Sydney here. I'm aware that stars are classified by their spectral types, and our Sun is a G2V type. Given that life exists, at least on Earth, a G2V star is obviously conducive for supporting life. However, life on Earth can be troubled by our Sun's UV radiation and other factors. I was wondering whether our Sun is the most ideal star for supporting life, or whether there are better stars to focus our search for life on other solar systems. Thanks for an amazing podcast.
Thank you, Neil. I have a simple answer for you. Skin cancer. You're spot on.
Well, there you
The
go,
sun
that's right.
sucks.
Yeah, ultraviolet. That's right.
Yeah.
I
So I'm
don't-
going to guess that it's, and I know we've sort of talked about this before, but I'm going to guess that there may be better candidates for us to orbit and live on or around compared to our own sun. Not that we've got a choice in the matter.
No, not really. To do a disclaimer here, because what I'd refer Neil, if Neil's interested in this issue, there's a fantastic article on that good old standby Wikipedia under the heading Planetary Habitability. Planetary habitability, and it goes into the kind of things that we're talking about. What are the pluses and minuses of living on planets around particular types of stars? And clearly, the Earth is one that can support planets. It's certainly got all the requisites in terms of things like water, abundant water, which is the working fluid for life as we know it, Jim. It's got the kind of minerals that we seem to need for life as well, and the rare earths and things of that sort. But there are other classes of star that have advantages. And just really to pull one out of the air, we know that the most common are these dwarf stars. And in fact, red dwarf stars are cool stars, and they're the commonest. Some of those are a bit unfortunate because they spurt out a lot of solar flares or stellar flares. But in general, those smaller dwarf stars might offer a better shot at life-giving organisms because they've got a much longer life themselves. So you've got these things last for many billions of years than the sun will. So if life takes a long time, several billion years to get going and to evolve, then your dwarf stars might actually be better. They give you more time. There's a an interesting classification as well that was proposed by an author by the name of Lemmer. I don't know that author's first name because I haven't looked at the reference properly. With a possible classification of water-dependent habitat types. So class 1 is bodies that don't keep water, and I suppose Mars is an example of that, a class 1, or maybe that's a class 2. Hang on. Yeah, class 1 habitats are planetary bodies on which stellar and geophysical conditions allow liquid water to be available at the surface along with sunlight, so that complex multi-celled organisms may originate. Class 2 habitats start off like that, but don't last like that, which includes Mars and possibly Venus.
Yeah.
And then there's interesting stuff which are called class 3 habitats, planetary bodies where liquid water oceans exist below the surface, where they can interact directly with a silicate-rich core. That, of course, means places like Enceladus and Europa. Yeah, that's right. So that'd be a class 3. And class 4 habitats, oh, this is interesting, liquid water layers between 2 ice layers.
Ooh.
Or liquids above ice. And the Wikipedia actually suggests Ganymede and Callisto, 2 moons of Jupiter, are likely examples of this class. In other words, the oceans are between 2 ice layers. It's, as they say, in such conditions, the emergence of life forms may be very difficult because the necessary ingredients for life will likely be completely diluted. Much is written on this page at least, and probably many others, about the habitability of planets. Well worth a look.
Yeah. When it comes to what kinds of stars would be best to orbit, it sounds like the dwarf stars are
the best, yes.
Prime candidates, and ours ain't.
Yeah, so there's no point in looking for life around the sun, obviously.
Nothing to see here.
Nothing to see here. But of course, our very nearest star, apart from the sun, is a dwarf star, Proxima Centauri.
Right.
Unfortunately, it's one that does spurt out these flares, but it is one that's got an Earth-like planet around it, or Earth-sized anyway.
Yes. I don't think it'll be long, Fred, before we find an Earth-sized planet in the Goldilocks zone of another star that has the right parameters.
Yeah.
There's got to be planets out there that are like ours, about the same size, about the same proximity from their star in that right environment. There's got to be squillions of them, to be honest. But so far we've found Earth-like planets that are too big, so gravity would be a problem.
That's right. Yes, and other such issues. Things that are too big within the habitable zone, the Goldilocks zone. Yeah.
But I did see an article the other day that there's a really big search about to begin. Now, I can't remember who it is. Might have been the Japanese, might be the Russians, not sure. But they're going to start it's the Chinese. They're going to start a really big search for an Earth-sized planet in the Goldilocks zone of a star that will effectively give them the right formula. They've actually just started that project, apparently, or are about to.
Yeah.
So we'll keep an eye on that if they ever tell us what they're doing. But yes, great question, Neil, and thank you for asking it. It's always interesting to sort of speculate as to whether or not we're in the best possible place, and we're not. As the case may be.
Come to the wrong place.
Yeah, it's always like that. Oh, damn it! Why did we stop here? Anyway. That is where we're going to wrap things up. Don't forget, if you've got questions for us, jump on our website and send them to us. You can text through your question via the email interface on the AMA tab, or you can just send us an audio question. Don't forget to tell us who you are and where you're from. And you can do that on the AMA tab or the send us your audio question tab on the right-hand side, spacenutspodcast.com or spacenuts.io. And while you're there, visit the Space Nuts shop and check out all the news as it rolls in. It updates very regularly, and don't forget to look at the potential of becoming a patron and putting a little money in the kitty to keep us alive and kicking, so we can buy Fred a new computer. And don't forget, review Reviews. We love your reviews. Please keep them coming in on your respective podcast platforms, whether that's iHeartRadio or iTunes or whatever platform you use. Your reviews are most welcome, and we appreciate them as well. And don't forget social media. We're all over that. Fred, thank you so much. It's been a joy to catch up with you again. We'll see you next week.
Sounds great, Andrew, and thank you very much, and we'll talk soon.
Very good. Professor Fred Watson, astronomer at large, part of the team here at Space Nuts, and thanks to Hugh in the studio, who's basically stitched us all together. He found some string on Mars to tie it all up for us today, which was good. I knew someone had put it there. And from me, Andrew Dunkley, thanks for your company, and we'll join you again on the very next episode of Space Nuts. Bye-bye.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
And thanks to our live audience who've been watching on various platforms, Patreon, YouTube, Facebook. Thanks for